So let's talk about finding standard deviation. Now we can find that weighted average. We want to know, how do we expect that to differ? So just to tie into how we calculated standard deviation before. So what we're trying to get at is that average distance away from the mean. So we want to know, how do these data values differ from the mean? So in terms of what we did before for standard deviation, what we had to do is think about those squared deviations, so each x value minus the mean squared. So we thought about those, and what we wanted to do was average them. So we tried to average the squared deviations, and to add on to that, so we added up our squared deviations, we divided by, and with standard deviation for that case, we had to divide by sample size minus 1, but we can kind of at least ignore that for right now. Let's think of it as we had those squared deviations, so each x value minus the mean squared. We added them up and divided by sample size, and what we actually had to do is take the square root of that larger number. So once we found that, we would take the square root, so I'm just going to add into the wording that we had this square root that really came in at the end of the calculations. A lot of that is going to come through here. What's really going to change, though, is in terms of taking the average, we want to make the same adjustment that we just did for expected value. So with the expected value, it was the idea of multiplying by the probabilities instead of just adding up and dividing by how many there are. So with those expected values, and let me write this out. For expected value, which we'll need to know because that'll be our mean, we were adding up those x times p of x values. So with our data, what we found was an expected value of, we found, 47.4. By taking the multiplication of x times p of x plus x times p of x, and by doing that, by multiplying by their probabilities, that took care of our idea of an average. It's just that we're not dividing by a single number, it's that each value is getting multiplied. And in a way, this is carrying out that division piece that can be kind of not uncomfortable, but a strange part of the idea of average. We're used to that idea of dividing by something, but that's coming through in this multiplication of the probability. So what we want to do is think about our squared deviations. So with our table, we have these x values and their probabilities. So let's think about what it looks like to have our squared deviations. So we want to take each x value minus the mean squared. So our x values are going to come from the table, and then our mean is going to be the expected value. So what we'll do is take 30 minus 47.4, and we want to square that difference so that we're only getting positive values out. 36 minus the mean squared, 42 minus the mean squared, 48, and 60. All right, so we'd have our squared deviations, and then it's the idea of averaging them, which before required adding them up and dividing by sample size, or rather sample size minus 1. But again, we want to kind of use the tools that we used when finding expected value. Instead of adding up our x values and dividing by how many there are, we carried out this multiplication with their probabilities. And that's exactly what we're going to do here. So what we want to do is take each of those squared deviations and multiply by its matching probability. So like with the 30 value in this first piece, since we're using 30, this squared deviation, we want to bring through that this variability happens 5% of the time. So what we want to do is scale that squared deviation by 0.05. And then similarly for 36, that only happens 20% of the time. So that squared deviation only happens 20% of the time. And so on and so forth. So each squared deviation is going to be multiplied by its matching probability. So this takes care of the averaging idea, which at this point, without bringing through the square root, if we take those pieces and add them up, so if we take the sum of those, that's going to give us our variance. At this stage, we could get a value for variance, which just like before with standard deviation in the last lesson, variance isn't going to be too helpful. However, it is a stepping stone to getting standard deviation. So for variance, I'm going to use this notation of VAR of X. So just in case you need that number, you can kind of go through and plug all of this in, which at that point, let's go ahead over to a calculator and I'll show you how to type this in. I know this will take a little while, and if you want to skip ahead, if you're comfortable with the calculator, you can skip ahead. But what we'll want to do is take our first value, so that 30 minus 47.4, and we'll want to square that, which you can use the button, and then multiply that by 0.05. So there's our first term. And then what we want to do is add that together with the next piece. So then going to our data value of 36 minus 47.4, and then square that, multiplied by its probability. And then we want to just plug in all of these. Now, with the last time that we looked at standard deviation, there was a shortcut that you could use with technology. Unfortunately, in this section, this does just have to be typed in. And it's good to do this slowly and pay attention that everything's typed in correctly, which I hope I'm not making a mistake while I say that out loud. And because any little change will affect your numbers. So when you get the standard deviation out though, when we make a sentence, we can kind of double check that it makes sense. All right, and multiply by 0.35, which is good. Okay, that's exactly what I wanted. So sorry, there's a car honking. Okay. So 104.04, that would be our variance. So this came from, on our table, having our squared deviations times their probability and then adding each of those up. And when we add those, we'll get our variance, which was 104.04. And then our last step to get to standard deviation is to take a square root. So standard deviation, which I'll write as SD of X, is the square root of that 104.04, which is 10.2. And if you're in the calculator, we could have put a square root right at the beginning of all of this and had calculate, or if you hit enter, you can do square root, and then you can either copy and paste, or, I mean, this rounded pretty nicely to do decimals, but if it was messy, what you could do is take square root, and there's this answer button that will just copy and paste the exact answer from your previous calculation. So you can see that 10.2. All right, so in terms of interpretation here, how we make our sentence is going to be basically the same as how we did it before. So expected values tells us what we expect to sell. So we have the cafe expects to sell about 47 cups of coffee in a day. And on average, this differs by about 10 cups of coffee. So then we get more of an idea of the variability of our data. And so with our expected value, we can get an idea of where we expect to land, but then we can understand how that number could change on average. All right, so for standard deviation, what you're going to be using is basically and this will look a little strange, I'm just trying to avoid very confusing notation that can come up with this, but you'll basically have a big square root, and then it'll be the sum of, and what you're doing is you're taking each x value minus your expected value squared, so squared deviations, times their probability. That's what comes down to. How I'm going to solve it is I'm going to keep showing it in this structure here. I kind of like the flow of this, of starting with those squared deviations times their probabilities, adding them up to get your variance, and then taking the square root at the end to get your standard deviation. You kind of follow those 3 steps, it'll get you there, and that can be more helpful to follow than just kind of one big formula coming through there. So that's standard deviation for our discrete random variables.